Good evening. I am Somapna, a research scholar at School of Mathematics and Statistics, University of Uttarakhand. So today I will solve problem from assignment 5 of previous year. So first I will show you the question. So question number 2, is this okay? Visible?
Yes, sir. Visible now.
Ah.
Elliptic curve.
So the question is that which one of the following is the set of all points in the plane at which the partial differential equation this is of elliptic type. So I will first write the equation. Question number 2. The PD is given by y square equal to x2 plus 2y plus 6 plus 1 plus square x plus u equal to u. So as you know that a PD, you have to compare this PD with the general form and you have to find b square minus ac, right? So if b square minus ac is negative, then it is of electric type. So I will compare this with the general form of PD, that is coefficient A is the coefficient of uxx, B is this coefficient of uxy, and C is coefficient of uy. Okay. So let me write what is A here. A is my y square, A of xy. A of xy. Equal to this is y square, and b is this is my 2b, the coefficient of uxy. 2b is minus 2y plus x, and I compare with the general equation 1 plus plus minus. Then what is my b? I have to find b square minus ac. It is same as finding b square minus 4ac also, because then my b is this minus 2y plus x minus y plus x. So now b square minus ac is y square plus square minus y square into 1 plus plus square. So it is simply minus y square. Okay. So we need to b square minus ac is negative, that means minus y square is negative. So this means what? Y square is positive. So is it okay? So this means this will happen when? Tell me when it will happen. Y square is always positive. When it will happen? Ruby,
So, y
tell
square always positive.
Y square always positive or non-negative? Only y.
Yeah, it can take non-negative values also, no? Y.
মানে y square, what should I write? Y square strict, is it always positive or is it always non-negative? It can be zero also, na? If y is zero. Suppose y is
But
zero.
sir, it should be greater than 0. So y will be uh, Y can take all value except 0.
This will happen for all y except y equal to 0. That means x-axis. Understand? So let me write it clearly. Just one. You are right. Really. So the answer is that it will be of elliptic type when y square is positive, but we know that y square is always non-negative, either positive or zero. But that means that it will be of elliptic type for all y except y equal to 0 line. That is except x-axis. So I will show you the question. Question is saying that which one of the following is the set of all points in the plane at which the PDE partial differential equation is of elliptic type. So what will be my answer? It's all point except y equal to 0 except x-axis. So my answer is option E. No? R2 minus the x-axis. R2 plane minus x-axis. So my answer is E. The accepted answer is also E. So is it okay? This will be
Yes,
of
sir, correct.
so
Sir,
my
once check option C also, no?
okay. I will just option C. Okay. Option C is saying that those xy such that cos square x is less than 1 by 3 and y non-zero. There are two conditions. One condition is on x, one condition is on y. So from my calculation, it is of elliptic type if only condition on y, right? There is no condition of x is coming, right, from b square minus ac, because this y square cos square x cancel out now. So only my condition is on y from b square minus ac. If suppose it is on condition on x also, then I have to consider for x. So three is saying option C is saying that y non-zero is okay, fine, but it is also saying cos square x less than 1 by 3. There is also one condition in x, but it may happen that cos square is greater than 1 by those x for which cos square is greater than 1 by 3. This also, for these points also, this equation is of elliptic type. It's not it, because there is in b square minus ac there is no condition on x that is coming from this PD. Okay. Or should I? You want to say something, Ravi? Hello? You understand?
God, sir, proceed. Yes, sir, God, sir, proceed.
Now there is one condition on x, but in my calculation there is no condition on x. So the answer is R2 minus y equal to 0. So R2 minus x-axis. So answer is E, option A. Option E. That is R. Sorry. Okay, fine. So I will move to next question then. This is question number 4. Is it visible? Consider the partial differential equation this. So this is of consider the partial differential equation this. So for first of all you tell me it is of which type? Elliptic, parabolic, or say hyperbolic. Consider a coordinate chain of transformation given by gi and eta, which reduces the given PD into its canonical form in a neighborhood of 1.1. So xi is already given, you have to find eta. Okay. So let me first write the equation, then I will tell you what it is of which type first. The equation is given by del 2 del x2 minus Now tell me it is of which type. I will write A at Robi.
Yes, sir. Good.
So B is minus, what is B square minus AC in that case? 1 minus 1 into 1. So if B square minus AC is 0, then the equation is of which type?
B square equals to AC.
Then if B square equal to AC, so the equation is of which type? Parabolic, elliptic or hyperbolic? You don't know, or then I will tell you.
Sir, parabola then, no?
Parabolic. I will write it here for your convenience. If suppose B square minus AC is 0, then it is parabolic. If B square minus AC less than 0, then it is elliptic. And if B square minus AC is positive, greater than 0, then it is hyperbolic. Okay. So here B square minus AC equal to 0, so it is a parabolic type. Now you have to, what the question is saying that, question is that, let me show you the question. The partial differential equation this, which is of, I already checked, it is of parabolic type. We have to give a coordinate transformation, coordinate change transformation given the xi and eta. This is of x, the coordinate is here x and y are the independent variable. U is the dependent, but we have to give a new transformation xi and eta, which reduces it to its canonical form. I think that you know canonical form what is, and in general form, in a neighborhood of 1, 1. So you have to find the which transformation I have to do. So Shashank, is it visible now your question?
Yes, sir, it is visible.
Okay, fine. Okay, so I will solve this question now. So the method is that you have to first let me write what is the coordinate change you have to give. Uh, Coordinate transformation is coordinate transformation is xi equal to x plus y. They are saying, and eta equal to function, any function of x and y, that you have to find what is psi. Question is that you have to find what is psi. Okay, let me go to the next page. Okay, so here it is a parabolic type already. So I will solve by the equation for characteristic, and then I will find what are the possible solution for that. As you know that in the last day also, uh, so it was did this. So this type of problem. The equation, but it is probably last day it was of elliptic type. This time it is of parabolic type. So you will get only one single characteristic. I will tell how it is coming. The equation, for the characteristic are given by this equation. What is the equation? Equation is that dy dx equal to minus b. Sorry, dy dx equal to b plus minus root over b square minus ac by a. Is it okay? You know now this equation for characteristic. So I will just solve this equation and find the characteristics along which we want to change the code. Okay. So dy dx equal to, here my b is minus 1 and a and c, b square minus ac is 0. I already found it. So b is my minus 1. Minus 1 plus minus root over 1 minus 1 into 1 by a is also my 1. So I will get dy dx equal to minus 1. For suppose for elliptic and parabolic type, what happens is that this b square minus ac either negative or positive. So for this case, there is one plus minus something will come now. But for parabolic type, you will get only one single equation. dy dx equal to only minus 1. Okay, so what is the solution for this? This is dy equal to minus 2x. So that means dx plus dy is equal to 0. So that means x plus y equal to constant. So one condition, one solution is x plus y. That is, xi is my x plus y. It is already given. Now you have to find eta. Okay. The question is, the coordinate assumption is given by xi equal to x plus y and eta equal to psi xi. Already I found xi. That is my equation. Now what is eta? Can you tell what will be the possible thing for eta? What is the condition for that? Anyone? Otherwise I will tell. Let me show you the question. Xi is I found x plus y. In the last time what happened is that it is of hyperbolic type. So xi and there are two equations. So you got xi and eta. But here it is of parabolic type. So you got only one equation. So you got that. Now eta is what? What are the possible choice? Can you tell me what should be the condition for xi and eta? Anyone? I like the condition. Since this one is equal to 0, so there is only one family of real characteristic. Anyone can you unmute and tell me what will be the condition for that?
Sir, both are orthogonal.
No, not orthogonal. Okay, I will tell. No problem. Actually, you have to take xi and eta in such a way that xi and eta should be functionally independent. You know this term, functionally independent. What? Hello, Sasan. You know what is functionally independent?
Sir, yes, sir. Functionally independent. Both are not in multiple or in same line.
That is for point, I should say. That linear combination, something you want to say, I think.
Yes.
But actually, functionally independent is the Jacobian is non-zero. Jacobian. I will tell you what is the thing. Let me write
Yes.
it. Actually, you have to tell what happened. Okay, I will compare with the last time what happened, and then it will be clear for you, I think. So last time, in question number 3, what happened is that dy, you got one is dy, it is of, I think it is of hyperbolic type, so you got dy dx equal to some y plus minus 1 or something. So you got the solution are log ln y plus minus x. So one is ln y minus x and another one is ln y plus x. But here this time what happened is that here I got dy dx equal to only 1. Because only minus 1, because it is a parabolic type, so this combination is 0. So only this term will produce here. Only there is no plus minus term. So another eta you have to find such that xi and eta are functionally independent. In the last time also, that ln y plus x and ln y minus x are functionally independent. You can check it. So the condition I will write condition. So eta should be such that is xi and eta are functionally independent. So that means there is no functional relation between chi and eta. That means chi is not a function of eta. Any function. Pi is any function. Pi is any function. Or you can say reverse also. Eta is not a function of chi. Something like that. So that is. So that means is that the condition for functionally independent is that the Jacobian. But I should write it in concept 3. That is. It is xi, the derivative of xi with respect to x, that is xi x. Derivative of xi with respect to y. Derivative of eta with respect to x, and derivative of eta with respect to y. Okay, this Jacobian is non-zero. Then I will say the function xi and eta are functionally independent. Okay, is it okay up to this? Hello.
Yes, sir. Audible.
It is okay na? Now I will show you the options here. So here any functionally independent function of xi will be taken as eta. Any functionally independent function of xi will be also will be taken as eta. Now I will show you the options. Let me go to the next option. So now tell me, option A is psi is y. That means psi means eta here, right? Here eta is equal to psi. So eta is my y. So xi and psi, I have to check the Jacobian it is non-zero or not. So let me write the option A. Option A is saying that psi is my y. So what is the Jacobian? My xi is I am writing here. Xi is my x plus y. It is given and I already found also. So Jacobian is my psi x. Psi x is what? 1. Psi y is 1. Psi eta, sorry, not psi, I should say xi. Xi x is 1, xi y is 1. Eta means such a psi. So eta, what is eta x? Hello?
G.
0. And eta y is 1. So it is 1. Determinant is 1, the Jacobian is determinant. So this determinant is 1, that means non-zero. So should I take this psi or not? Should I take this eta or not? I should say eta every time. Huh? So should I take this eta or not?
Yes, sir. It will take.
It will take. So option A is right. Because psi and xi, let me write one line just. Xi and so my xi and psi are functionally independent. So option A is correct. So now I will show you option B. Option B is that psi is my eta is e power x into e power y. Now tell me. I will write first. My eta is psi is my e power x into e power y. Where my xi is that x plus y. So is it functionally dependent or I can write xi as a function of eta or not? Or eta as a function of xi or not? Tell me. Without calculating this Jacobian also it can be.
Sir, equal to 0, sir. Jacobian equal to 0.
No, you if you calculate, the Jacobian should be equal to 0. But without calculating Jacobian also you can tell now this time, because see here, e power x into e power y is what? E power x plus y, right? So e power x plus y means e power xi. So xi is a, so eta is a function of xi. It is happening now, or you can say xi equal to log of y. So basically log of eta. So also xi is another function of, say it is phi 1 and phi 2. So it is already happening now. Means xi and eta are functionally dependent this time. So it is not, this functionally independent case I will not consider. So this is false. Without calculating Jacobian also you can tell. It's not it. Also Jacobian also equal to 0, because if I consider the Jacobian becomes 0. But without the calculating the Jacobian also you can take the xi and eta functionally dependent. Functionally dependent means there is one function such that xi can be written as function of eta, or eta can be written as function of xi, anything. So is it okay up to this, or you want to find the Jacobian? Without Jacobian I
No,
do.
sir. Correct, sir. Correct. Got it, sir.
Without Jacobian it is easy. No need to check the determinant. Okay, both of you, Shashank and Ruby.
Yes, sir. Yes, sir. It's okay.
Okay, so now I move to option C. Option C is psi is x. So it is same as y. What is psi is x? Let me take psi. Eta is my psi. That is x. Okay, so Jacobian is what? Xi is my x plus y. So 1 1. What is this 1? And this is 0, right? So what is the determinant? Minus 1.
-1.
So minus 1 is non-zero. So I can, so xi and eta are functionally independent. So option C is also correct. Now option D. Option D is that my psi is sin x plus cos y. So now tell me, psi my eta is eta of x is psi equal to sin x plus cos y. So what is my Jacobian? This is 1 1 fixed xi x xi y. What is eta x?
So minus.
Is it okay? What I wrote? Ravi or Shashank?
It's okay. It's okay.
Yes, sir. Correct, sir.
So the answer is minus sin y minus cos x. The answer not. I am saying the Jacobian is this. That is minus sin y plus cos x. Now tell me. Now the point, it is in a neighborhood of some point you have to calculate this. Not in every whole region. You have to count canonical in a neighborhood of the point 1, 1. In a small neighborhood. So tell me it is 0 or non-zero in the neighborhood of 1, 1. There it is suppose 1, 1 point. So I have to take a small neighborhood of 1, 1, and this is x-axis, this is y-axis. So it is non-zero or 0? Sine and cos both are
Non-zero.
non-zero, because sine and cos are both are non-zero na, in this neighborhood, first coordinate. First, second, third coordinate. Sine and cos both are non-zero, so and both are positive also. So the total is, the Jacobian is negative. That is non-zero, I can say. So in a neighborhood of 1, 1, Jacobian is non-zero. You have to write here non-zero in a neighborhood of 1, 1. Actually, everything you have to consider in neighborhood of 1, 1 for everything.
So this 1, 1, is it given or what?
Given.
This point 1, 1.
I am showing you the question. Consider the change of transformation xi and eta reduces to the given PD into its canonical form in a neighborhood of the point 1, 1. Is it visible?
Yes, sir. Got, sir. Got.
Actually, what happened is that in the other cases also, this j is minus 1, this j is 1. It is true for any point. And in 1 comma 1 also it is true. It is true for 1 comma 2 also, because it is independent of x and y. So Jacobian is non-zero everywhere. But for this particular option B, the Jacobian is non-zero in this scenario. Also, suppose suppose they give 1 comma 2 point also, then also this option is correct. It's not it, because it is non-zero. But suppose they give 0 0, then it is not true, because at 0 0 it is 0. No, sorry. Suppose they give 0 pi by 2, then suppose they give 0 pi by 2, then
Sir, 5/2, 0.
I think yes, pi by 2 comma 0, because x is pi by 2. Yes, suppose it is giving pi by 2 comma 0 point in a neighborhood, then it is not true. You understand? Because sine cos pi by 2 is 0 and sine 0 is also 0. Then option D is false in that case. Understand, Robi? You tell me the correct thing, pi by 2 comma 0.
Yes, sir, got sir.
So option D is correct. So my answer are A, B, and D. Okay. So A, C, and D. B is not there, because B is e power x plus 1. It is e power j. So A, C, and D. Okay. Correct, no? Hello. So I will move to
Yes, sir.
next
Yes, sir.
question. Then I will move to question number 6. Is it visible? You have to look carefully the question, because it is a true and false type. So you have to look carefully every options. Is it visible now, question? So I will let me use. Question number 6 is that consider the two family of planar curves phi and equal to phi x equal to constant, and psi is d, another constant, where phi and psi are continuously differentiable function defined for x comma y in R2. That is, phi and psi are continuously differentiable. The derivative is continuous. Which one of the following statement is a true? So let me first write what they are giving. Then I will show you the options again. Let's move to the next page. Question is the question is that consider two families of planar pen. Phi equal to constant and psi. Okay. So now I will show you what are the options given, because you have to check true and false type. There exists no partial differential equation for which the given families of curve are characteristic. Can you tell anything? There exists no partial differential equation for which the given families of curve are characteristic. First tell me what is how we find the characteristic curve from which equation? This equation, dy dx equal to b plus minus b square minus ac by a. From this equation, you find the two characteristics of phi and psi. So these two functions are the solution of this equation, right? The phi and psi. Let me name this equation as star. So phi and psi are solution of star. Is not it? Characteristic curve. So what is option A is saying? Option A is saying that there is no partial differential equation for which the given families of curve are characteristic curve. Is it possible? There are no PD for this.
False, sir. There are PDs.
There are PDs, because phi and psi are given curve. So I can write some equation for phi and some equation whose solution and phi are psi. Okay, like the last time also. As in question number say what I did, is I and eta this thing. this xi is my phi and eta is my psi. So I can easily find the equation between PD, right? So option A is false. Option A is that option A false, false because we can always write the
Sir, one example, please write, sir.
one example I will give you. I will give. We can actually I can give example from the questions only. So we can always write. Let me first finish this slide. I will always need to families of curve or characteristic. Okay, your example is that suppose my phi is, suppose I move to question number say question number 3, huh? So suppose my phi, this is a xi and eta, this is phi and psi, that already given. So lny minus x is my phi and lny plus x is my psi, because my answer is lny plus x. So you can find the equation now. Find the equation, right? Like phi is my, so ln y plus minus x and psi is my ln y plus x. So you can write the differential equation, right? Just by differentiating this derivative. Like in my case, what I did is that I found x plus y equal to c. This is my phi. Phi is my x plus y, right? So I can differentiate this phi and get this equation, right? Where my discriminant is 0. Then I can write the PD. I can write any PD. I have to only write the coefficient of del 2 del x2 as 1, coefficient of del 2 del x del y as 2 and minus 2, and this is del 2 del y coefficient is 1. And the rest other thing I can change. This thing I can change. I can change by anything. Because my this discriminant depends only on the derivative of highest power, the coefficient of highest power. Do you understand what I mean to say about by the example, or I should say like no, Ravi. Do you understand what I want to say by you are saying the example? Sasanka Ravi, you understand? We can always write the differential equation by this function. Hello?
Yes, sir.
Okay. Then move to option B. There is exactly one partial differential equation for which the given families of curve are characteristic curve. Is it true? Only one you can get. Suppose you know the you know phi and psi, you construct the equation. Now is this the unique equation? What do you think? This is
No, sir, false.
but why?
Uh,
Suppose
we can always
okay. What you said, we can always. Hello. What you want to say? Tell me. No problem. Oh, I think okay. I will. Actually, let me give you first the example. Then I will tell you. As in my last example, in question number 4, what I did that. Suppose for option say A. what I got? My phi is x plus y and my psi is y. So the my for option, say here, so take suppose phi is x plus y and my psi is y. Okay, so what is my equation in that case? Already I got from the given PD is that del 2 del x2 minus 2 del 2 del x del y plus del 2 del y plus 3 del u del x minus a plus 1. But I can find a, b and c from only from this portion, the underlying portion. So if I by unchanging this portion, if I change or add more linear terms here, then the equation, then also for this for the other equation also phi and psi are the equation of characteristic part. The PD I change by unchanging the first by unchanging the highest order derivatives coefficients and by changing these coefficients or removing or adding some extra term. Is because my phi and psi depends only on a, b and c. I can find phi and psi by this equation d by dx equal to b plus minus e power b square minus ac by a. Is not it? So my a, b, c if I keep unchanged and if I change this lower order term, then we can construct different PDs, not a unique PD. There are infinite number of PD. It's not it. You understand what I want to say?
Yes, sir. Got, sir.
So we can always, so the answer is that why it is false, because we can always construct an equation with phi and psi as the characteristic by giving an infinite number of distinct lower order. Lower order means del u del x, del u del x, del u del y we can add or subtract. Or maybe we can remove this u, maybe we can replace 1 by 2, then we get another different type of PD, infinite number of PD. So unique PD is not true. And the option B is false. So the idea is that we can always, the reason is that we can always construct an equation with this phi and psi as the characteristic uh, by giving an infinite number of distinct lower order. So infinite number of distinct lower order. Lower order means del u del x, del u del y, or u you can say, or constant. Okay. Example. So I will show you then what is the option C, D, E, or the C. So option C is saying that there is exactly two partial differential equations such that the given families of curve are the characteristic of for each one of them. Is it okay? It is also false, na? Because I got infinite number, not exactly one, not exactly two. I can find any by changing the lower order term. So my option C is false. Is the option D is correct or not?
Yes, sir. Option D
Yes,
correct.
sir.
Because there are infinite many partial differential equations such that the given family of characteristic, because we can change only the lower order term, so that we got infinite number of PDs just by changing coefficients or variable or anything or constant term. So I move to option E. Option E is saying that if for every xy the Jacobian is non-zero, then there exists exactly one partial differential equation for which the given families of curve are characteristic. So what you say? If the Jacobian is non-zero, there is exactly one PD.
No, sir.
False, sir.
Why? You have to give reason.
By adding constant, we can change the PD. Still,
Yes.
the differential will be same.
Ah,
Jacobian will be same.
yes. By adding infinite number of what can I say? Let me write C.
Constant value by adding any like.
E is such a false because by adding, by giving an infinite number of lower order term, if for every x, let me write it clearly. Option E, I will show you again the question. Question that if for every xy the Jacobian is non-zero, then there exists exactly one partial differential equation for which the given families of curve are characteristic. That is false because if suppose for every xy in R2 the Jacobian J, that is dn by del xy is non-zero, then there may exist infinite number of PDs for which the given families of curve are characteristic. So by adding or what should I say, by changing, I can by adding or changing adding or changing more linear terms, more distinct linear terms, one can get infinite number of people. The reason you have to know, otherwise you get infinite number of PDs. Okay? Is it okay? Understand?
Sir, wait for few seconds, sir. Previous slide.
Yes, you are. Which one? Will be? Previous one?
No, sir, the last one of this question. This one, sir. Please, few
Oh,
seconds.
I just suppose the equation is del 2 del x2 minus 2 del u del x, that del 2 del x, sorry, del 2 del x del y plus del 2 del y. This will give you A, B and C. From these only you can find 5 answer, right? But suppose you write 3, other equation you write plus 1 plus del u del x. Now in another equation you write u plus u or minus u, anything. Then what you got different PDs now. This is one PD, this is suppose this is same thing plus 1 plus u. This is same thing minus u equal to 0. All are these are different PDs now, so we got infinite number of PDs. Okay. Or also Jacobian non-zero. You got now as in question number 4, you got na Jacobian is non-zero here. Okay, but you can get infinite number of PDs by just changing this linear part. This linear part, 3, this portion, 3 del u del x, this portion you can change by anything. Then you got the linear, different PDs, infinite number. So let me here and here. I just remove this portion so that it's not sitting. Is it okay? Is it okay? Or I wait for some time?
Sir, correct, sir. Proceed.
Okay. So I will move to next question. This question is over. Okay. So question number 7 is already done, 9 done, and question number 10. Question number 10 is that you have to just some calculations. What is that under the coordinate transformation, y is e power minus 1 minus e power minus x and eta equal to e power x, what the partial differential equation becomes 1. You have to just give some coordinate transformation. Okay. Y and eta. So I will write this equation. You look carefully my calculations because this is huge. Calculation are huge, means you have to find derivatives 2 times. So my y is that e power minus y minus e power minus x, and eta is e power x. Okay, so I will write the equation. Equation, the given PD that you have to change is that e power 2x del 2 del x plus 2 e power x plus y del 2u del x del y plus e power 2y del 2u del y2 plus e power 2y minus e power x plus y del u del y. What you have to, the question is that you have to change the coordinate. xy are the coordinate independent variable. You have to change it as xi and eta. So I will give some, the transformation is that let w xi and eta is a function of x and q is x of y. And I can write like ux function of xi and eta and y a function of xi and eta. I have to make this transformation. Okay. So I write in terms of u everything, and at last I will change u by x or u by w. Okay. So for your convenience. So what is ux? Tell me. Ux is what? U is a function.
So the e power
W eta.
Write in terms of u first, then so that it will be easy for you. U is I, then I can replace u by w na at last. That will be good because the equation is in terms of u only. U x x, u x y, u y y. So
sir, please once again, sir, this from beginning of this question.
hey, you tell me whenever you finish. Then I will do the practice.
Sir, this transformation once explain, no?
Actually, transformation is given in the question. Xi equal to e power minus y minus e power minus x and eta equal to e power x. This is the given. This is. Let me show you the question again. Under the coordinate change transformation, xi and eta, the partial differential equation this transform to which one of the following equation? They are not mentioning what is w, but I will tell you that I just calculate everything in terms of u and then replace w by u by w. And w is a function of xi and eta, but u is a function of x and y. W equal to u. Okay. So this is the question. Question is clear? Under the coordinate transformation. So I will move them. Ravi.
Yes, sir, proceed.
Okay, so ux is what? Ux is u xi into xi x plus u eta into eta x. You know not this from calculus of several variable. You know this thing, how it is coming. U is a function of xi and eta, xi is a function of x and y. So ux is del u del xi into del y del x, del u plus del u del eta into del eta del x. So where my xi is, and now we write xi and eta, what is there? E power minus 1 minus e power minus. So what is xi x? Xi x is e power minus x. What is eta? Xi y. Xi y is minus e power minus x. So now let me write eta equal to e power x. So what is eta x? E power x. What is eta y? Is 0. Is it okay? I just calculate xi x, xi y, eta x, eta y, and I put it here. Is it okay, Robi? Or Sasan?
Yes, sir.
Okay, u xi, so xi x is my e power minus x plus u eta into eta x is my e power x. So I found ux. Now I have to find uxx. Differentiation of ux with respect to x again. So let me write it here. Uxx is del x of ux. Is it okay? Just check del x of, now ux is my what? Ux is u xi into e power x minus x plus u eta into e power x. Okay? I just replace ux by this time. I will go to next step. So this is equal to, I just break this del x of u xi. Let me write u xi e power minus x plus del x of u eta e power x. now I calculate this both the derivatives. So I just u into v formula, differentiation, nothing. Del u xi into first I differentiate of u xi, then I am differentiating e power minus x, then again u eta, then again. This is okay, this line is okay. Hello. This line you understand, no? Anyone?
Yes, sir. Chain rule multiplication.
Just u into v. Yes. So now I will calculate this term, del u del x of u xi. Therefore, u xi is a function of xi and it again, na? So this is del xi of u xi into del xi del x, that I am writing as xi x, plus del eta of u xi into eta x. You know this line is okay. From this is up to this only. Into e power minus x minus u xi into e power minus x plus again u eta. Eta is again a function of u eta is again another function. So this is del xi of u eta into xi x plus del eta of u eta into eta x into e power x is there. Into u eta e power x. Okay, this line.
Sir, please read this above line, sir.
Okay, it is not visible. Okay, I'll
मतलब
do it.
visual just.
Okay, actually what happened is that I just differentiation with respect to x of u xi. That is differentiation of u xi with respect to x means what? What I wrote here. Differentiation of u with respect to x is what? U xi into xi x plus u eta into eta x. You know now this. Just now I wrote for only u. Now replace u by u xi. Nothing. I did not do anything except this. Replace u by u xi. So the same thing. So the differentiation is del xi of u xi into xi x plus del eta of u xi into eta x. Now from here also replace u by u eta. Then you get del xi of u eta into xi x, del eta of u eta into eta x. This is okay.
Yes, sir. Correct, sir.
So I am writing this. Now del xi of u xi means u xi xi. Del u del xi 2, right? Del u del xi 2 is u xi xi. The xi x is my e power minus x that I already wrote previously. And this is u xi eta. Into eta x is e power x into e power minus x minus u xi into e power minus x plus what is del xi of u eta? U xi eta into xi x is what? E power minus x plus u eta eta into e power x, right? Into whole thing into e power x plus u eta e power x. Okay, is this visible and okay? Then I will go to next one. I just multiply with e power x, nothing I will do. This is x, no, not eta. This is x. U xi xi into e power minus 2x plus u xi eta minus u xi into e power minus x. That is again I multiply with e power x plus u xi eta plus u eta eta into e power 2x plus u eta e power x. Tell me this line is okay or not up to this. Power minus 2x plus u eta eta into e power 2x plus 2 u xi eta minus u xi. I just take the change this. Okay, after this, then this is uxx. I got uxx. Now I have to find uxy. Xy means del y of ux. Up to uxs it is fine, Robi and Sasan. Or you have any question or anything? Hello, tell me.
Yes, sir.
Okay, then I am writing uxy now. Okay, what is ux? Ux is u xi into xi x. Xi x is e power minus x plus u eta into eta x. Eta x is e power x. Okay, so what is now I will just do the same thing as I did earlier. Del y of u xi e power minus x plus del y of u eta into e power x. So e power x and e power minus x will comes outside. So del y of u xi means del xi of u of xi into xi y plus del eta of u of xi into eta y. Now e power x come out, e power minus x come outside. Therefore, if this line is okay, from this part I am writing this. Is it okay? Similarly, for it also. How it is coming, you understand now? Hello. Tell me if you have any question, you can also tell me. I am replacing xi y and eta y. Eta y is 0. Eta y is 0. Robi and Sasank, any question? Xi y is now equal to eta y is 7 0. Any question? So I am multiplying with e power minus x and I will get like this. You understand? So now I am to find u y y. This up to this, any question you have? Hello. Hello.
Yes, sir.
Yes,
Okay.
sir.
No question, na?
No, sir.
Okay, okay. You understand this thing what I wrote? Just I differentiate using chain rule. Del y of uy means again I have to do del y of u xi y plus u eta eta y. Now my eta y is u eta y. Now my eta y is 0 because eta is given e power x. So I will just write u xi into e power minus y plus, I think here is one minus, yes, minus e power minus y. Let me write it here. U xi into minus e power minus y plus u eta into 0. So I have to calculate del y of u xi into e power minus y. So here, so this is minus del y of u xi e power minus 1. So this is equal to minus del y means this is again u v formula use I into e power minus 1 plus use I into derivative of e power minus 1. So what is this? Again I will use chain rule here. So del xi of uy sorry into xi y plus del eta of xi into eta of y. This into e power minus 1. This is just minus uj e power minus 1. So I write minus u xi into xi y is what? Minus e power minus 1 plus u xi eta into eta y is again a 0 into e power minus 1 minus u xi e power minus 1. So this is e power minus 2y u xi plus e power xi into e power. Tell me, this is minus is there, so this minus and minus plus, and even here minus. So minus plus. Which is okay? Up to this. So on substitution uxx, uxy. On substitute uxx, uxy, uyy, and what is uy? We got from the given question what do we get in uy? Let me first write the equation. E power is a huge equation. E power 2x into uxx plus e power 2 power x plus y into uxy plus e power 2y uyy e power minus 2y e power 2y minus e power x plus y into uy equal to 0. Now I just replace what I got. Uxx, uxy, this thing, uyy, uy. Okay. I'm writing. This is equal to x into uxx I got as u xi into power minus 2x plus u theta into power 2x plus 2 u xi minus u xi into power minus x plus u into power x. This is my uxx. Now I write uxy. U power x plus y into uxy is minus e power minus of x plus y u xi minus e power x minus y into u xi plus e power 2y into what is uyy? Uyy is e power minus 2y into u xi plus u xi into e power minus 1. And what is this term? uy. Uy is only minus u xi into e power minus 1 equal to 0. So you have to calculate this. Just multiply. And you got u xi plus u eta eta to the power 4x plus 2 u xi eta to the power 2x minus u xi to the power x plus u eta in the power 3x minus 2 u xi xi minus 2 to the power 2x u xi eta plus u xi xi plus u xi into the power y minus u xi into the power y plus u xi into the power x plus y minus x equal to 0. Okay? Up to this it is okay? We are used to that. It is okay now? Is it okay? Shashank and Nobin?
Yes, sir.
So now check which term are cancel out first. U xi xi, u xi xi, 2 u xi xi. These are cancel out. Here is one u xi xi, here is another one u xi xi, and here is minus 2 u xi xi. So this cancel out. Now u xi eta, this and this cancel out. This and this. Okay? Now u xi power x, u xi power x, u xi power x cancel out. And any term? Any other term?
U eta e to power minus e to power y.
U xi power minus y, this term also cancel out. So answer, so I got what of the remaining term? The remaining term is u eta eta to power 4x plus plus u eta to power 3x equal to 0. So if I take e power 3x common, so I take u eta eta e power x plus u eta equal to 0 because e power 3x non-zero. Just to take common. So what is my e power x transformation? E power x is eta, na? Eta is my e power x. I have to write the equation in terms of eta and xi, not in terms of x, y. I give the transformation xi equal to e power minus y minus e power minus x and eta equal to e power x and the beginning. Remember? Okay. Yeah, xi equal to e power minus y e power minus x and eta equal to e power x. This is my transformation. So I got the main equation on substituting everything, I got this. So I just now I replace u by w. So that it reduces to this equation. Eta into, I just replace u by w. So w eta eta plus w eta equal to 0 or equal to 0. So let me show you the options now. The options are del eta del 2 w del eta 2 plus del w del eta equal to 0. Option B. Just check, accepted answer is B. So is it okay? Option B. Any question? Shashank and Modo. Is this okay? This problem?